Hello everyone, this is the second lesson recording for IM1, May 21st, 2021. Okay, so far we found the value of x to be 8.89 when 79.1 is equal to x squared. So x is equal to 8.89 to 2 decimal places. Next problem. This time I have 21.1 plus x squared is equal to 63.9. The numbers are getting more tricky, isn't it? Okay, what do I do? Okay, to figure out what you should be doing, you need to be thinking about, all right, when you had problems like say 79.5 plus 7x is equal to 57.2. Okay, what would you do? Would you add or subtract first, or would you divide by 7 first? Divide or multiply by 7 first. You added and subtracted. Why did we do that? Because undoing, it's going opposite to what you do. It's like opening a present to figure out what's inside. You need to think about what was the very last thing that was done to x. The very first thing that was done to x was it was multiplied by 7, and then whatever the value was, it was added by 79.5. So to undo, you need to tackle the very last thing that was done to it, which is adding 79.5 to it. Okay, so how did I undo adding 79.5? I subtracted 79.5 from both sides. Okay, so it's the same thing, but instead it is being squared. Okay, if you look at the order of operation, should I be adding 21.1 plus x first? Should I be doing this first, or should I be doing the exponents first? Remember JAMDAS? It says that grouping symbol, then exponents, multiplication and division is next, and then addition and subtraction is at the bottom. That means we need to do exponents before addition and subtraction. So this is adding. So that means x is being squared first and then added by 21.1. So to undo, we need to get rid of 21.1 because that was the very last thing that was done to x. So how do I undo adding 21.1? This is like plus 21.1, which is same as adding 21.1 to the value. So I subtract 21.1 from both sides. Okay, and that leaves me with x squared is equal to 63.9 minus 21.1. And that's going to be 9 minus 1 is 8. 3 minus 1 is 2. 6 minus 2 is 4. So it's going to be 42.8. So now I have x squared is 42.8. How do I figure out what x is? Well, I don't want x squared. I want x. So I am going to take a square root of both sides. When I do that, squaring and square rooting, they cancel each other out. Left hand side, you're just left with x is equal to, then pull out your calculator and figure out square root of 42.8 is 6.54 to 2 decimal place is what I get. So I have just figured out what value of x has to be in order for this equation to be true. Okay, and then lastly we have this question. X squared is equal to negative 39.91. Okay, so how do I do that? Again, I am going to take a square root of both sides because I don't want x squared, I want square root just x. And when I do that, squaring and square rooting, they cancel each other out. And you're just left with x on the left hand side. And on the right hand side, if you use the calculator and get a square root of negative 39 or 37.91, what do you get? Okay, let me try that again. 37.91 and take a negative of it and take a square root of it. I get error. Okay, error 30. Okay, so why is that? That's because what we are looking for is two numbers that multiply to itself that will get you negative 37.91. Can you ever get a number that is going to end up with a negative number? Okay, so if I would say multiplied, let's make it simpler. If I have square root of negative 9, okay? I am looking for two numbers that multiplies to 9, negative 9. So I'm looking for x times x is equal to negative 9. What do you think the x could be that multiplies to negative 9? Could it be maybe some of you are thinking negative 3. Okay, if x is negative 3, x times x squared is negative 3 times negative 3. What's negative 3 times negative 3? That's positive 9. And what about 3 times 3? That is also positive 9. So can I ever get a negative 9 as a result of multiplying two numbers to itself? No, it's not possible. That is the reason you get an error message here. It has to be always positive. Later on in IM2, you are going to learn about complex numbers where, yeah, it is actually possible to get a square root of negative number, but that's a whole nother story. That's something to look forward to in IM2. Okay, so then let's continue. Alright, I'm going to show you a video called Pythagorean Theorem, Science of NFL Football. And I am going to let you watch that yourself. So what did we learn from the video here? Okay, so when you have a runner with the ball and there is a defender here, he wants to get to catch up with the player with the ball as soon as possible. Now, if he was to go this way, okay, if he was to just follow where he is and go this way and then go all the way up like so, that's a long way. He's going to go 30 yards plus 40 yards, so he's going to go going 70 yards. What is the shortest way that he can get to the player? Is by drawing a direct line all the way like so. Okay, it should be a straight line. So instead of going the green pathway, the shortcut will be to go just join those 2 points, because that's where we are expecting the player to end up in. So he's going to go over there. And how do I calculate that distance so that I can figure out how fast I need to be running? Well, that's where the Pythagorean theorem comes in. So you're taking notes here. Parts of right triangle. Okay, so in a right triangle, how do we know this is a right triangle? What's a right triangle? It's a triangle. Triangle just means three-sided shape, and with a right angle. And here is my right angle, so that is the reason we call that a right triangle, right? There must be a right angle. There must be a right angle. Right angle is what? What is the right angle? That is 90-degree angle. So this is the symbol for 90-degree angle. And that's what right angle is. And the two sides that make the right angles are called legs. So what do we call the legs? It's one side here. Right next to the right angle is one leg, leg 1, and there is another leg the other side of the 90 degree is called leg 2. Okay, and the side opposite to the right angle, this is my right angle here, is called the hypotenuse. So opposite means across from. When someone is sitting opposite you, they're sitting across from you. Okay, so it is across from where you're sitting is this side here, and that is the hypotenuse. So the pink side is the hypotenuse. The legs are adjacent or right next to the right angle. Okay, so two sides that are right next to the right angle are called the legs, and the pink that is across from the right angle is called the hypotenuse. And it's not hippopotamus, it's hypotenuse. And have a look at the spelling. I'm not going to be too picky about the spelling, but it will be good if you can figure out how to spell it correctly, for my sake, please. Alright, so then Pythagorean theorem. Okay, what is Pythagorean theorem? It says for any right triangle. Okay, it only applies to right triangle. If it is not a right triangle, you cannot use Pythagorean theorem. The leg, we have one leg here, and leg squared plus another leg squared, the second leg. If you square that, and you add those two lengths together, then you are going to get the hypotenuse squared. That's what Pythagorean theorem says. And this applies to any shape of right triangle. Okay, notice that it doesn't matter whether it's a skinny one, whether it's sort of more of equal length, or whatever the shape. As long as we are dealing with one of the angle being a right angle, so therefore it's a right triangle, Pythagorean theorem is always satisfied. So to solve using Pythagorean theorem, so if I have solved for x, if I'm trying to find the length of this, and if I know one leg is 3.1, the other leg is 5, how do I do that? Well, the Pythagorean theorem says that leg 1 squared plus leg 2 squared is hypotenuse squared. So what type of side is a variable? Okay, so variable is x. Is that variable the leg of the right triangle or the hypotenuse? Okay, the legs are you find your right angle symbol, and either side of the right angle, the sides next to the right angle are the legs. That's what we call legs. So 3.1 is my leg and 5 is my other leg. And so x is the hypotenuse because it's across from the right angle. So then write the correct Pythagorean equation. So we identify x to be the hypotenuse, and these two are the leg. And then you finally need to solve. So what's the variable? X is my hypotenuse. Okay, and so it's hypotenuse. And what about the equation? It's the leg 1. I can call this the leg 1, or I can call this the leg 1. Does not matter, because when you're adding, the order does not matter whether it's 3.1 squared plus 5 squared or 5 squared plus 3.1 squared. When you're adding, the order does not matter, right? So 3.1 squared plus 5 squared is going to be x squared is my equation. And then from here, I just need to solve. 3.1 squared, remember I do exponents before addition and subtractions. 3.1 squared is 9.61 plus 5 squared is 25. So when I add these two together, the left hand side simplifies to 34.61 is equal to x squared. And then from here, what do? I use my calculator. That's what we've been working on. Whoops. Okay, that's what we've been working on. You take a square root of both sides to get rid of the square sign, and you're left with x on the one side of the equal sign is equal to 34.61. Square root of 34.61 is what I'm looking for. So 34.61, and I get 5.88. So that length is 5.88. That's just what I found. Now you're going to be working on Desmos activity.